Hello! Today's lesson is being sent to you using a special type of radio. The radio transmitter is in Great Britain, over 4,000 kilometers away. Using high-frequency radio waves, the signal can travel long distances to reach you. High frequencies have long been used for radio broadcasts, but now there is a new technology called DRM, which stands for Digital Radio Mondiale. DRM is digital radio. It lets broadcasters transmit high-quality audio, such as speech and music, along with extra data or information. This data can include drawings or diagrams to help you better understand the audio content. Today, we are going to use the extra data to demonstrate a simple maths lesson. It is all about triangles and squares. We hope you will enjoy it. Today's lesson is about shapes, or polygons, which means a shape or an object with many sides. The two simplest examples of polygons are triangles, which all have 3 sides, and quadrilaterals, which all have 4. We are going to look at triangles and quadrilaterals and find out more about the relationship between the length of their sides and the angles between them. Triangles are particularly interesting, as there are several types of triangle which have special rules about their angles and how to calculate the lengths of their sides. Over 2,000 years ago, a Greek philosopher, astronomer, and mathematician by the name of Pythagoras discovered that there are some very interesting and very useful facts about triangles, which even today are commonly used in everyday life and work. But he also found some special types of triangles, which we are now going to look at in more detail. The first of these is the right-angled triangle. A right-angled triangle will always have one angle that is a right angle, or 90 degrees. This means that the other 2 angles must add up to 90 degrees, because the total must always be 180 degrees. Now, in the Journalline menu structure, please go to Mathematics, Geometry, Lesson 1, Page 1. You will now see an example of a right-angled triangle. The angle at the bottom left-hand corner is 90 degrees, shown by the square box in the corner, because it is a right-angled triangle. If one of the other angles is, for example, 60 degrees, well, we know that all the angles must add up. So the missing angle must be 30 degrees. 60 plus 180. Another special type of triangle is the isosceles triangle, which always has two angles the same. Now in the journal line menu structure, please go to Mathematics. This is an isosceles triangle. Because this type of triangle always has two angles the same, working out the other angle is very easy, as again, all of the angles must add up to 180. In this example, both of the angles at the bottom are 75 degrees. So added together, that's 150. That means that the angle at the top must be 30 degrees, because as always, all of the angles must add up to 180 degrees. 75 plus 75 plus 30 equals 180. Now, in the journal line menu structure, please go to Mathematics, Geometry, Lesson 1, page 3. Let us have a look at another special type of triangle, the equilateral triangle. This is the easiest to calculate because in an equilateral triangle, all of the angles are 60 degrees. So 60 plus 6 is 180. Not only that, but in an equilateral triangle, all of the sides are the same length. But we'll look at how to calculate the sides of different types of triangle a little bit later. Now, in the journal line menu structure, please go to Mathematics, Geometry. Finally, there is the scalene triangle. Unlike all of the other types of triangle that we've looked at so far, all of the angles of a scalene triangle are different. Each one of the three angles are different, but once again, they will always add up to 180 degrees. In this example, 58 plus 77 plus 45 equals 180. Now, in the Now let us look at quadrilaterals. The and four angles. All of the interior angles in a quadrilateral add up to 360 degrees. In a rectangle, where the opposite sides are parallel, each angle is a right angle, or 90 degrees. You'll now see an irregular quadrilateral. Angles are different, but once again, they all add up to 360 degrees. You can check this for yourself. 80 plus 94 plus 68 plus 118 equals 360. Now, in the journal line menu structure, please now go to Mathematics, Geometry, Lesson 1, page 7. Now that we have looked at the of triangles and quadrilaterals, now let's find out. Once again, triangles have some special rules which Pythagoras discovered. The rules are called Pythagoras' theorem. Let us look again at a triangle. The longest side of a triangle, labelled C, is called the hypotenuse. The hypotenuse is always the longest side of a triangle, and it's always opposite the right angle. Pythagoras found something very interesting about the lengths of right-angled triangles and how they are related. He discovered that if he used the hypotenuse of the triangle to draw a square, C, then the area of that square would be exactly the same as the areas of the two squares formed by the other two sides of the triangle, labelled A and B, added together. The area of a square is found by multiplying the lengths of the two sides together. So in the case of the diagram, the area of by A, which is often written as A squared. The same applies to the square formed by side B. The area of square B is length B multiplied by B, or B squared. So, just to repeat, Pythagoras' theorem states that the area of square C equals the area of square A plus the area of square B. Another way of writing this is C squared equals A squared plus B squared. Now, in the Journal-line menu, please go to Mathematics. Pythagoras also found a special case, which is known as the 3-4-5 triangle. Let us suppose that the length of side A is 3 units, and the length of side B is 4 units. We already know from Pythagoras' theorem that the area of square C equals the area of square A plus the area of square B. Now turn to page 9. We know that 3 squared equals 9. That's 3 multiplied by 3. And 4 squared equals 16. That's 4 multiplied by 4. So, putting those numbers into Pythagoras' equation, C squared equals 9 plus 16. Therefore, we now know that C squared equals 25. And the square root of 25, in other words, the number which needs to be multiplied by itself to make 25, is 5. So the length of side C is 5 units. Pythagoras found that this relationship is always true, provided that the lengths of side A and B are multiples of 3 and 4. For example, 6 and 8, or even 300 and 400. We will always be able to work out a missing length providing we know the other two. The length of side C can always be calculated using the same equation. C squared equals A squared plus B squared. And that is the end of today's lesson. We hope that you have enjoyed it and that you now know more about triangles and quadrilaterals and how to work out their angles and the lengths of their sides. Goodbye and see you again soon.
Bienvenue à la leçon d'aujourd'hui. La leçon d'aujourd'hui est particulière. L'émetteur radio se trouve à des milliers de kilomètres de distance, en Grande-Bretagne. Grâce aux ondes courtes, le signal peut parcourir de longues distances pour t'atteindre. Les ondes courtes sont utilisées depuis longtemps. DRM est un système de radio numérique. Il permet aux diffuseurs de transmettre un son de haute qualité, comme la parole et la musique, ainsi que des données ou des informations supplémentaires. Ces données peuvent inclure des dessins ou des diagrammes pour t'aider à mieux comprendre le contenu audio ou pour y revenir plus tard. De plus, des devoirs et des ressources complémentaires, dans autant de langues que nécessaire, peuvent être fournis. Aujourd'hui, nous allons utiliser ces données supplémentaires pour démontrer une leçon de mathématiques simple portant sur les triangles et les carrés. Nous espérons que cela te plaira.